Hello, welcome to the video demonstration of Hall effect setup. Hall effect setup is a very useful system for the laboratory. It is used for the study of Hall effect in semiconductors. The Hall effect is an important observation in material science. If an electric current flows through a conductor in a magnetic field, the magnetic field exerts a transverse force on the moving charge carriers, which tends to push them to one side of the conductor, producing a measurable voltage between two sides of the conductor. This voltage is Hall voltage. This is the experimental setup of Hall effect. It contains electromagnet assembly, power supply for electromagnet, Gauss meter to measure the magnetic field, Hall probe containing semiconductor, constant current source multimeter to measure the voltage. Let's start the experiment. We will start with determination of different magnetic field intensity with the help of power supply for electromagnet. As the current will flow through the coils, a magnetic field will induce between the two poles of the electromagnet. We will measure this magnetic field with the help of Gauss meter. Just insert the Gauss probe, center it between the two pole pieces. Now switch on the power supply and open the current adjusting knobs at their maximum position. Start adjusting the voltage until we get the desired amperes for electromagnet. We will start with current of 1 ampere, note the respective value of magnetic field in kilo-Gauss for 1 ampere, repeat the same for 2, 3, 4 ampere and note value of magnetic field respectively. Now we have got the different magnetic field intensity for different currents. As the current increases, magnetic field also increases. After this calibration, we will move now to the experiment's second part, that is to study the Hall voltage when semiconductor crystal is placed in magnetic field, how it produces a measurable voltage. Insert the Hall probe, fix it on the clamp so that it comes in between two poles perpendicularly. Now make the connection, switch on the constant current source power supply. Give small amount current to the semiconductor, note the respective voltage on multimeter. Now switch on the electromagnet power supply, provide the current of 1 ampere. We have already got the values of magnetic field at different currents. What you will observe that when we place semiconductor in the magnetic field, the value of voltage changes. This is known as Hall voltage. Repeat the experiments for different currents magnetic field to see the change in semiconductor behavior.